And here we go. So today we're moving on to domain and range of discrete functions. Specifically, you might remember discrete is discontinuous, discontinuity, disconnected is another way to say it. Okay, that's different than the normal continuous connected functions that we've seen. Okay, now you can see here that what's due is what we did yesterday. You can see it right here. 9 key features of linear equations. Y'all got it yesterday. Okay, turn that in when you're done. You might have some time to finish that today and start today's assignment after that, which will spill into tomorrow. You will have time tomorrow to work on this assignment. However, notice also we have a test on the 19th coming up, so we still got over a week, but there it is. So on test day, no one's going to be like, test? I had no idea. Okay. It's on the board every day, right? Alrighty then, let's answer these questions. Number 1, what are 3 other names for an x-intercept? Who can give me one? Root, okay? An x-intercept is a root. What else could it be called? Solution, that's a good one. What else? 0, okay? So sometimes there's only one. These are all singular, but sometimes it's plural. Sometimes there's x-intercepts, roots, solutions, zeros. But these are great, okay? You got to know these. I'm going to keep asking you them because you just got to know it, okay? So repetition can lodge it in your memory bank. I believe it. Number 2, can you solve for y? Now look, doesn't this look like something we did on test 1 in the review? And I said it's weird because you can't use Desmos to solve this because there's an x and a y. So let's remember how to do this because guess what? It's never going away. It will haunt us forever, okay? This is definitely what you got to know how to do in Unit 2. So here's a reminder. When I want y by itself, what do I got to do with that x? Got to get rid of the x, right? You can't leave that x there. The x has got to go. Now, how do I get rid of a positive 4x? What's the opposite of a positive 4x? Negative or minus 4x. Very good. So write that down. Minus 4x, minus 4x. Scratch that out on the left. Now, please remember, negative 8, negative 4x, they don't combine. They're not the same thing. One has an x, one does not. So remember, the x term goes in front of the regular number, the constant term. Okay? So bring down 2y, bring down equals. Don't combine negative 8 and negative 4. They're different. So we're going to write the x term, which is negative 4x. Then we're going to write the constant term, minus 8. Last step. Y is not by itself. There's a 2 coefficient. How do I get rid of that 2? The opposite of the invisible multiplying here is to divide everything by 2. Does everyone know that second step is dividing everything? Okay. So the 2's cancel. Now I have y equals. Now, if you're stuck on how to reduce those fractions, at this point you could use Desmos. You would normally have a Chromebook, not right now, but you could, right? But I also hope you can just divide numbers. So what's negative 4 divided by 2? Negative 2x. What's negative 8 divided by 2? Negative 4. So you end up getting y equals negative 2x minus 4. Here's some notes. Domain and range of discrete graphs more than just graphs, but good enough. Yeah. Okay. Here we go. Here we go. Oh, what's going on here? What's going on here? Okay, there we go. Alrighty then. here we go. First things first, domain and range of discrete graphs. We have our learning intention and our success criteria. Okay, you can read that, but here's what we're doing. Functions, okay, data that's discrete also, okay, it's like a factory or a machine. You put something in, you get something out, right? So this says all the values that go into a relation or function are a part of the, write that down, domain. These are the X values, and you can underline the word input. These values are our input. So you see your little function factory over there? You plug in the X, you plug in the domain, you plug in the input. And then inside the factory, math happens. It's mathemagical. And then you get what? An output, a range of Y values, okay? So again, the second part, all the values that come out of a relation or a function are a part of the range. These are our Y values. These values are our output. And notice this last little piece here. Both relations and functions, there's a little S supposed to be there, have domains and ranges, okay? So sometimes you'll see some points and it's not a function, but you can still find the domain and range, okay? That's the basics of that. Now, there are 3 rules to writing domain and range. I'm going to give it to you all at once. Step 1, you got to use brackets. Step 2, you got to do it from least to greatest. And step 3, you cannot repeat any of the numbers, okay? So with that being said, I'm going to leave this here, give you a few minutes to copy it down. All right, so again, here's the rules. Everyone looking up here. If you're writing, finish writing, but hear what I'm saying. When you write domain and range, you have to use brackets. Not parentheses, not the square looking ones, but the squiggly brackets, okay? Y'all might remember we talked about these when we did Desmos inequalities. You have these brackets around the inequalities. Anyways, so you got these brackets. That's called set notation. It's called a set. Now, number 2, when you write them, no matter what your numbers order is, you got to put them in order from least to greatest. Rule 3 here is that you cannot repeat it. So if there's more than one of the same number, you just write it once, okay? So we're going to take that and we're going to apply that on the example at the bottom. Now, if you look at this example at the bottom, kind of weird because it's not, oh my gosh, hold on one second. I'm going to scream. What the heck is going on here? Yes, okay, so example 1, here we go. It says state the domain and range of the following relation. Now this is weird because it's not numbers, it's eye color and name. Kind of weird, but we can still do this. Remember, it's always X before Y, like you're saying oxygen, right? Alphabetically, X before Y. Okay, so is it a function? Now how do we tell if something's a function? X does not repeat. Don't remember that from our notes? X cannot happen more than once. So look at all of our X values, all of our eye colors. Is this a function? What do y'all think? Is this a function looking at all those X values? No, because does X repeat? Do I have any repeating eye colors? Blue and green. Blue happens more than once. Sophia and Dante. Green happens more than once. Justin and Elvis. Since the X repeats, it is not a function. No. No. Because X repeats. Blue and green. Cool. Now, we're going to write the domain. This is a little bit weird because it's on numbers, so we can't put them in order, but we are going to put a bracket because we have to put set notation, bracket, and we're not going to repeat any of these colors. So we'll write blue once, not twice. We'll write green once, not twice. And we'll write brown, call it a day, put a little bracket on the end, okay? Do you see how this works? Brackets in order without repeating. Range, now look at all these Y values. You got Sophia, Justin, Madison, Dante, Elvis. There's no repeaters, so you put a bracket and you're just gonna write all these names. Sophia, Justin, Madison, Dante, Elvis. Cool. All right, once you have that, you can flip it over to the back so we can look at example 2. If you want to get a head start on example 2, give it a shot. Flip it over, try an example 2. All right, here we go. Example 2. Does anyone still need the example 1? Example 2, here we go. State the domain and range. Now, domain is X, right? Look at all these X values. Is it a function or no? What do y'all think? What does that mean? No. Why is it not a function? Yeah, the 1 repeats. So is it a function? No. Why? X repeats. Comma, it's the 1. Y'all see that here? 1. Repeating. Not a function. That means X has more than one Y. Does not function. Okay? Oh my gosh. Whew. All right. Domain. What do I have to start with? Rule number 1. Bracket. Okay? Put a bracket. Okay. Now we got to put the X's in order without repeating. What's the smallest X you see here? -2. What's the next biggest X? 1. 1 repeats, but we're only going to write it once. The next biggest X I see is 3, and then I see 4. Okay? That's it. There's only 4 domain values for my 5 points because there's a repeater that we do not write. Next is the range. What do I have to start with? Brackets. Now look at all these Y values. What's the smallest Y value? -3. So -3, it repeats, but I'm only going to write it once. Next up, the next smallest Y value I see is 3. The next smallest Y value is 5, and then 7, and that's it. Okay, do you see how to do these? You put the X's in order from least to greatest. You put the Y's in order from least to greatest in brackets without repeating. Look at example number 3. Now this time we're given a function in function notation, the f parentheses x. We don't say f parentheses x. We don't say fx. We say f of x. That's the parentheses of. So f of x is equal to -3 parentheses 1 minus x, right? Okay. Now, we're given a domain of 1, 2, and 3. That's discrete. We want the range, which will also be discrete. So we're going to take this discrete domain, put it into that function, and we're going to end up with a range, a set of Y values. So here's the deal. when you're given a domain and you have an equation, you have to plug it in, evaluate it, analyze it, okay? Substitute it, okay? You're replacing x with whatever the domain is, and you're going to end up with a y, the range. So everybody, go ahead and write these. Go ahead and give yourself 3 equal spaces here, okay? So draw these lines. Try to make them as equal as you can, okay? It's not going to be perfect. Heck, mine aren't perfect. Just do your best. So with these 3 spaces, we're going to plug in these 3 domain values into that function, okay? All right, so here's the deal. We're going to write this f of x equals equation, but instead of x, we're going to put the first domain value, which is 1. So go ahead and write f of 1, write small so you can fit it in, equals -3, parentheses 1 minus, and instead of x, I'm going to be putting that 1. Do you see how I replaced this x with 1? Okay, and I'm going to do the second one with a 2. So instead of f of x, I'm going to put f of 2, -3, 1 minus 2. And I'll do the same thing with the number 3. F of 3 equals -3, parentheses 1 minus 3. All I did was replace x with 1, replace x with 2, replace x with 3. That is called evaluating a function. Okay? Now, do y'all remember this from August 14th when we talked about PEMDAS, order of operations? That's how we're going to do it today, but I do want to let you know, if you do have a Chromebook in the future, which is fine, you could just plug in the right side of this equation and it'll evaluate it for you. It'll tell you the answer, okay? But today we're going to use our PEMDAS brains here. P for parentheses. Inside the parentheses here, what is 1 minus 1? 0. So really, this is going to be -3 times 0. What is -3 times 0? Or any number times 0? 0. Cool? Okay, f of 2. What's P for parentheses? What's 1 minus 2? What? -1. All right. 1 minus 2 is -1. So what's -3 times -1? Negative times a negative is a positive. 3 times 1 is 3. You're multiplying. All right, last one. 1 minus 3 in that parentheses. What's 1 minus 3? 1 minus 3 is -2. Again, this stuff you could do in Desmos if you need to. Type it in. But what's -3 times -2? Negative times a negative is a positive, and you multiply 3 times 2, and you get what? 6. Okay? Again, this is multiplying, not adding and subtracting. Multiplying. So negative times a negative is a positive. 3 times 2 is 6. Boom! So we have 3 y values now. Okay? So can you write that as a range? We know the domain is 1, 2, 3. We're going to write it as a range. So go ahead and put bracket, and the least to greatest without repeating is 0, 3, 6. Okay? See if you can already try that next graph. Example 4. Okay?
I can come back that one. Oh, yeah.
Everybody, look at example 4. Now, example 4 says, given a graph. Now, how do I get domain and range from a graph? Here's how. There's 2 ways to do it. Here's one way. Can't you write these points as ordered pairs somewhere randomly off to the side? Like, isn't this point right here, -4, +4? You could write that down, and then what? -2, -3, write that down. -1, 1, write it down. 2, -1, 3 +2. You could just write all the points down, and then it would just be like example 2. Once you have all the points written down, do it like example 2. Here's another way to do it though, okay? If I'm talking about domain is X, right? So all I got to do is take all these points and look at where do they line up on the x-axis, which is from left to right. Does everyone know that this is the x-axis, right? So remember, domain is from left to right. So on the far left, this point goes straight down to what number? What is that x value? -4. So put a bracket, -4, comma. The next dot over goes up. What's that x value? -2. Okay, this one, -1. This one, +2. This one, +3. Okay, so we got 5 points. All I do is look at where do they hit the x-axis. That's one way to do domain, okay? Now, for range, I'm looking at the y-axis. Okay, now I'm going to look from left to right. Okay, I'm going to look from bottom to top. Does everyone know this? Range does not start at the top. Range starts at the bottom and works its way upwards, okay? So what's my bottom point? Right here, this point, I'm going to look sideways over till where does it touch the y-axis? So what is that y value right here? It's negative, but it's not 4. Starting at 0, it's -3, okay? Then the next one, go over, the y value there is -1. The next one over, 1. The next one over, 2. The next one over, skips 3 and goes up to 4. Okay? Do you see how you can use a graph just to look over at the right axis? But here's the problem. Some people get confused on which axis to look for. So if it helps you, write down all the points and do it like example 2. Either way is fine. Okay? We got one more to do here. Example 5. Does anyone have questions on example 4? Example 5, here we go. Now be honest, if you look at example 5 on the STAR test, how many of y'all would just guess? All right. I should have said don't raise your hand, my bad. I have a feeling it's more than just a couple people. I have a feeling a lot of people would be like, you know what, I can just guess, because the STAR test is just a big old guessing game, right? Wrong! Okay? The STAR test is not a big guessing game. Let me tell you something. Y'all know the STAR test, like, you can't have your phone, and if you finish faster, guess what? You still can't have your phone. There's no, like, incentive to finish faster. So it's okay to just read the problem, okay? When I've asked other classes, I said, who reads the problem? A lot of people are like, I don't even read it. That's too much reading. I get it. Reading is work. But I'm asking you, let me first tell you, if you don't read, this is what you're doing to me. Right in my heart. Okay? Don't do that to me. It's hurting my math heart. It's making me cry on the inside. And then I'm going to get very full of water from all the internal crying I'm doing, okay? So here's what I want you to do. Make me happy and just read the problem. You might find out when you read it that it's not as hard as you thought it was, okay? When you look at this, is there an equation here somewhere? Is it just a bunch of words or is it an equation? What do you think? Well, if you read it, there's a hidden equation in all these words. And if you can find an equation, you're halfway to solving it, I promise you. Okay? So again, I know this might seem basic and Some of us, it's laziness. Some of us, we don't believe in ourselves. I don't care what the reason is. You got to read the problem. It costs you nothing. And I'm trying to prevent you from having to take the EOC more than once. Because you get in a cycle where you just take it over and over and over, and it's sad, sad, sad. You're a senior, still taking Algebra 1 EOC. Don't be that person. Read the problem. There might be answers when you read the problem. Okay, so let's read this together. Is everyone with me? Look, look, look. The total cost in dollars to buy uniforms for the players on a volleyball team can be found using a function. Here's our function. F of x equals 30x plus 5. Okay, it's $5 and then 30 times each person. Okay, U is the number of uniforms bought. And now this is important. There are at least 8 players, but not more than 12. So what's the players is between what two numbers? The least number is, let's read it again. There's at least 8 players, but not more than 12 players. What's the least amount of players? 8. What's the most amount of players? 12. Is there such thing as a half player or a decimal person? No. So it's either 8 or 9 or 10 or 11 or 12. It can be the least at 8. It can be the most, no more than 12. So, do you see how reading it, you can tell it's between 8 and 12? Okay. Now, what is it asking us to do? Now, how many of y'all think you're supposed to take 8 through 12 and plug it in? Who thinks you do that? We did it earlier, so maybe, but what does it say? What is the domain? Domain is what they give you, the people. Okay? I know this takes a little bit of extra thought, but all they're asking you is, if they tell you it's between 8 and 12, that's the domain. It would be a little bit more work if they said range. Then you'd have to plug it in. Okay? But domain is just between 8 and 12. So let's go ahead and write that down. It has to be in a discrete notation because people are not continuous. We are discrete. We are separated one whole person. So 8, 9, 10, 11, 12. That would be the input. If you put that into this equation, you would get an output of the money and costs for each volleyball player, total for the volleyball players' uniforms. But they didn't ask you how much does it cost. They didn't ask you for a range. They just said, what's the domain? Okay? So that being said, I'm going to give you an assignment. First, I want you to finish 9-9 yesterday's, and then you can work on this, but you will have time tomorrow, so don't sweat it. I'll also give you all time to do corrections tomorrow. It's okay. We're going to get it done. All right, here we go.